Good morning, Year 8. It's Mr. Sutton here, and I'm going to be introducing you today to the concept of biomimicry, designing things inspired by nature. And I think the robotic frog that I've got here is a perfect example of kind of the type of thing that I'm going to be talking about. We're not going to be talking about creating weird sort of amalgamations of nature and technology in the form of robots, but we are going to be looking at how nature can help us as designers to design things far better. And we can use what nature has learnt to help us to create things that work and are easier to use. Now, biomimicry is the science of using nature as an inspiration for modern design. Basically looking at the natural world around us and trying to learn from it. In design, we constantly change and improve and develop our designs. If you think about what we do in design lessons, we often ask you to start with a design brief, which tells you exactly what we'd like you to design. And then you try to come up with ideas. And you have to think about, well, are these ideas any good? Would they work? Would they be irritating? Would they be particularly good? Do they solve a problem? Do they have problems themselves that you need to overcome? Now, we can do that using our abilities, our knowledge, and constantly being creative and innovative, doing something different. But nature does the same thing, and we call this evolution. But nature takes a hell of a long time to do it, so things that we are seeing in the natural world have evolved over millions of years. And we can see that, like nature being a designer that's constantly trying new things out, and sometimes they work and sometimes they don't. So there may be a change in a particular organism's DNA that means that it has a different kind of outcome in its physical appearance or what it's capable of. And that might mean that it's more successful, or it might mean that it's less successful. And these tiny little changes build up over millions of years and mean that the animals become particularly adapted to surviving. Survival of the fittest. And that's really what evolution means. Each and every single stage is almost tested by the environment to see if it's any good. Now, we as designers would do exactly the same thing with things that we designed. We would get to a point where you might have a car that you're designing and you test it, put it in a wind tunnel, see how it goes. If it's quite economical, you might drive it around corners. How well does it respond? It's also test it when it's crashing. Does it protect the inhabitants? These are all little bits and pieces, and as designers we then look at those and change the design to make it better. And nature does exactly the same thing. It's called evolution. So biomimicry is where we as designers kind of cut out all of that development and try to use what nature has done and spent millions of years developing in our own designs. And that's exactly what we're going to be having a look at today. Now, some examples of what we can talk about, things like this. This is a wing of an Airbus plane. Now, Airbus have been looking at the way in which they can design their wings. Of course, they can use wind tunnels and models and computer-aided design. But they also look at, for example, as we can see here, an albatross's wing. An albatross is a particularly large bird, and its wing needs to be really well designed in order to lift that body weight. Now, a plane's wing has to do the same type of thing, so they look at the shape of the actual bird's wing, and you can see this angle here where it breaks and comes back is very similar to the angle that you see in the bird's wing. Now, that seems quite straightforward and simple, but we've also got a shark here. Now, a shark cuts through water like a bird cuts through air. It has to be really, really quick in order to capture its prey. So evolution has created not only its ability, its muscles, its shape and its fins to cut through the water, but also the way in which it's designed and developed and evolved its skin, because its skin is covered in these tiny little friction sort of bumps and texture. If you actually look at the skin of a shark, if you feel it, it's actually very, very rough, which seems strange because you'd think that a rough surface would actually be worse at cutting through the water, but it's not. It actually reduces what we call drag, and that is where the water in the case of the shark or the air in the case of the plane wing, where it flows over a surface, and drag is where friction, where it slows that surface down. So if you reduce the friction and increase the ability for a wing of a plane to cut through the air, it means that it uses less fuel. It can go faster, more efficiently. So they use the same type of things, and they replicate the shark skin on the actual plane. And you may well have seen that there was also people at the Olympics with the swimming team where they've done the same type of thing, where they've created materials that simulate and imitate shark skin to allow people to actually swim through the water quicker. We've also got a very famous one. This is a bullet train, as we call it in this country, or as it is actually called in Japan, a Shinkansen, which is a particularly fast train. Very, very famous. They streak at over 200 miles an hour across Japan, and they go very, very fast indeed. Now, one of the problems they had is that Japan is an interesting country in that it's quite mountainous in the centre, and there's only a certain amount of space around the outside where they can actually build buildings and people can live, which means that the train lines that these Shinkansen or bullet trains run along are constantly going past people's houses. They're going through areas where people live, and they were also having to go in and out of tunnels at very, very fast speeds. Now, what happens when you go into a tunnel at very high speed in a train is the air in that tunnel can be pushed suddenly out of the way, and this creates a shock wave, which we hear as a kind of a bang, as a loud noise as it hits that tunnel. And of course the problem is that would disturb the people who were around the area, who lived around those tunnels. So what they did is they looked at the shape, and this is a kingfisher here, the actual shape of both the head and the beak of the kingfisher, because the kingfisher, nature has evolved the head and the shape of the kingfisher to be able to cut through both the air, but more importantly water. So in the same way that the shark has been designed to cut through water, because a kingfisher needs to dive into the water very, very quickly and capture fish with the minimum amount of noise and disturbance to the surface of the water, its beak has been designed perfectly to do this. And so that's why they use that to help them to design the shape of the train. And you can see they've evolved it over time, and this is one of the more advanced ones, where you've got this very, very long, sleek nose to the train, which is very similar to that of the kingfishers. We also have something which we probably all experienced, and that's Velcro. Now, Velcro is a reasonably old kind of development, and it was designed, as you can see here, by George de Mestral in 1941. He was walking with his dog, as the story goes, and he noticed that these little burr-like seeds were getting constantly caught up in the dog's coat. You've probably seen them. And the reason for that is that they've been designed by nature that these little seeds from the trees fall onto the ground and they need to be dispersed. Now, a tree can't get up and walk around and plant its seeds, so it needs to find other ways of doing it. And nature has found many different ways of doing that. So it can be taken on the wind, it could be swallowed by animals in the case of fruit, and then comes out the other end when they go for a poo. But in this case, the burr seeds that the tree comes from, they have these little strange hooks, and those hooks are designed to grab hold of animals' fur and hitch a ride. So they basically jump on the back of dogs until they walk off, scratch them off, they come off naturally, and then they can grow. And he thought, well, this is a brilliant idea, and he came up with the idea of Velcro. And you can see one side of the Velcro is the little hooks, which are like the bits on the burrs, and you can see the little tiny hooks on the end, and the other side is just like the fur of an animal, and that means that Velcro works perfectly. You can open and close it many, many times before it becomes a problem. Wonderful and amazing invention. Now, there's many other different types of biomimicry in the world. What I want you to do today, though, is I'm going to ask you to have a look at this sheet. Now, I've uploaded this as a separate one just for you to fill out. So this has got a little student view one. And I'm going to ask you to find an image of a product that has been inspired by basically nature. And I want you to fill out the rest of the boxes around the outside of it with some of your observations, as well as some little close-ups. And we're going to have a look at the different places that will help you. Now, as part of the video and as part of the task, I've obviously uploaded this video that talks all about it, but I have also got a number of other things to help you out. One of them is a link to this, which is the Biomimicry Institute, and they have, under their biomimicry one, they've got loads and loads of biomimicry examples, and you can have a look through the different things on here. The other thing that I've done is I've got this great video. This one is a 6-minute video that talks all about why biomimicry is such a wonderful thing. It can be a little bit complicated at some points, especially in the latter part, but it does give you that example of the kingfisher and the Shinkansen train, as well as other bits and pieces, which I really think will help to extend your knowledge. So what I'd like you to do is not only watch this video, but watch that one as well, before having a look at the Biomimicry Institute. You can, of course, go on to Google and just have a look as biomimicry and have a search, because it brings up loads and loads of different types of things, as well as the Institute, as well as more explanations, but it gives you some different examples. And don't forget, you can have examples for kids. You can bring up loads of different bits and pieces and explain some of the things that have been done with biomimicry. And I'd like you to just see if you can find some products that you think are really, really interesting, and why they've actually been created, and how have they used biomimicry. Here's a great one. Look at that. Biomimicry. 10 best biomimicry images. And it's got here, well, it looks like a hammer, but maybe it's not. And it's using this bird, which looks like a woodpecker to me, to help to influence its design. So, when you go onto this one, onto the actual PowerPoint itself, if you come up on here, I want you to insert an image, a really nice image just here. Let me do it full screen so we can talk about it a bit more. And then I want you to answer these 3 boxes down the side and find some further images here. So a nice image of the actual product just there, and then close-up images of the features. So where I've got things like the Velcro, that would be a close-up image. Or where we've got, for example, the shark skin. So getting some little bits to help us to see why it's important. What is it that makes it important? Then we've got, when was the product designed? So I want you to think, the Velcro was from 1941. When was your product designed? Is it quite modern? Is it quite recent? Or was it designed slightly in the past? Is it quite an old product? And then, where is it located? Now, we know that that Velcro was that particular gentleman. Where was he based? So where was it invented? What country did it come from? Then, how has the product been inspired by nature? Think about its structure, its materials, or even its aesthetics, which is what it looks like. And I just want you to make a nice paragraph here. These paragraphs should be 3-part paragraphs, that PEE, point, evidence, explanation. So if I was going to talk about this, you can see the example here with Velcro. It talks about how he was walking his dog. It talks about the fact that the seeds got stuck to the coat, and that inspired him to realise he could create it. I want you to tell me about it. Don't cut and paste, put it into your own words as well. And then finally, what special features does it have? If we think about the Velcro, it's the little hooks that hook into the other side of it, the furry part. The Shinkansen, it's the shape of that nose of the train, it cutting through the air, it being able to enter and exit a tunnel without creating too much noise. And the shark skin is particularly, that rough texture is what makes it special. And I want you to put as much detail as you possibly can. Now, these individual slides, they can be uploaded to your teacher so that they can have a look at them and give you some feedback. Hopefully you've enjoyed that video and it's been nice and clear. It's a really interesting and exciting sort of topic, and when you look at it, it really makes you appreciate how many things around us can be influenced by the design of nature, how nature has evolved different bits and pieces. Hopefully it's something you'll find really, really interesting, Year 8, and I look forward to seeing some of your work and see what you come up with, because there's so many different products out there. I bet you're going to be able to find some really interesting ones. Take care, everyone, and I will speak to you soon. Goodbye.